This is section 9.3. We're going to find lengths in similar triangles. So we learned our three shortcuts. We need to apply one of them here to explain why the triangles are similar. We're going to write a similarity statement, and we're going to find this missing side, segment DE. I know these angles are congruent because they're vertical. That's really, really important. Now, I know two sides on either side, on both sides of congruent angles. So I'm going to attempt to use side angle side. So I'm going to compare 12 with one of these sides over here. I'm not just going to compare it with 24 because it goes into it twice. I'm not going to compare it with 24 because they're both on the top. I'm going to compare the 12 with the 18. Here's how I know 12 goes with 18. 12 is smaller than 16. 18 is smaller than 24. You put the two smaller ones together. If these triangles are going to be similar, which they're telling you they are basically, the two shorter ones have to go with each other. These two longer ones that touch the congruent angles, they need to go with each other. Now, what does this reduce to? 6 goes into both, 2/3. 8 goes into both, 2/3. So the similarity ratio is 2 to 3. They are similar by side angle side. So you need to write that. Explain why they're similar. Side angle side. You got two pairs of proportional sides, congruent angles in between. Write a similarity statement. Triangle ABC is similar to this triangle down here. A is in between the two smallest sides. Fortunately, I don't know that over here, but I knew this one went with this one, right? So E goes with A. So it's going to be EVD. Sorry, that's a little messy. How are you going to find this? We're going to call it X. We know the similarity ratio is 2/3. So that means this ratio is also 2/3. 2 times 5 is 10. 3 times 5, 15. That's how long this side is. Explain why these triangles are similar. Write a similarity statement and find X. I see a pair of congruent angles. That's nice, but it's not enough. I know this angle 30, so if that's 85 and that's 30, that's 115 degrees, which means that I got 65 degrees left to use for this guy. And that matches this guy. Angle is probably the simplest shortcut for showing the triangles are similar because you only have to find two things. If you know two angles in a triangle, you know the third angle. So that's probably the best way to go about this. In fact, it's really the only way. But if you have an option, I think angle is pretty easy. So why are they similar? They're similar by angle. Write a similarity statement. All right, we'll go 1 to 2 to the 30-degree angle. So we'll call this triangle L and M. It's similar to this triangle. We're going from 1 to 2 to the 30-degree angle, RQS. The order matters. Find the value of X, they say. We want to know how long this side is. Okay, well, I know these sides correspond because they're in between two pairs of congruent angles. So 12 to 8, we'll call that my scale factor. And I know that is just, 4 goes into both. 3 and 2 times. So the similarity ratio is 3 to 2. That means this ratio needs to be 3 to 2. Now I know this X goes with the 6, not because it's the only number there. Look at the angles, 85, 30. This is 85, that's 30. So the X goes with 6. 2 times 3 is 6, 3 times 3 is 9.